Hello everyone, welcome to this class. In today's class we are going to deal with congruent triangles. Now let's see the definition of congruent. It says two figures are congruent if they have exactly the same shape and size. Let's assume we have a triangle like this. We also have another triangle like this. You know, this triangle can be congruent, just that one was flipped. So what they're going to do in this class is to find how to know if they are congruent, irrespective of how it was drawn, whether this one was facing north, the other one is facing east. And that's what we are going to do in this class. The first thing you are going to know is that for a triangle to be congruent, two sides and included angle are equal. Let me see, are equal. So what it's trying to say is that when you have a triangle like this, let's have two triangles. This is the first one. Let's have another one. This is another triangle. I'm not drawing this thing to scale, mind. Let's call this one L, M, N. Let's call this one X, Y, Z. So first, you're trying to know if these two triangles have the same, remember the definition, shape and size. So from this first law, it simply says that if two sides are the same, and the included angle, what does it mean by included angle? The angle that is joining the two sides. See, these two sides meet at an angle, so this angle and this angle are also the same. You can now say that these two triangles are congruent. Now look at, I think in the last class I told you that when you are dealing with this geometry and you see these lines on the side, it means that those sides are equal. But when you have two different sides that are equal, you now start increasing the number. Like here, you see that it is 2 here now, and 2, showing that here and here are also equal. If maybe say here and here are equal, this time around you can make it up to 3, unless here and here is equal. In that case, you can still use 1. I hope you understand that. So this is the first law. Mind you, when you have something like this, let me say you have this triangle now. Let's have another one. Pardon my drawing. And let me call this A1, B, C, and call this A2, B, C. Now here we have these sides are obviously equal. Are we together? But now you have an angle here, and these angles are equal. So I want to clear something. I want you to notice that these are the sides that are equal. So for you to be sure that these two triangles are congruent, the angle that need to be equal, which is the third criteria, should be an included angle, something here, joining where the two lines that are equal meet each other. But in this case, look at the two lines that are equal. But look at where the angle is. See that this line is joining another line, so it's not the included angle. So you can't say that this triangle are equal. So in this case, we call them ambiguous case. Why do we call it ambiguous case? It means it can be congruent, it cannot be congruent, but we can't say for certain. But in the case where we have this criteria in this number, the first rule met, we can be 100% sure that this is a congruent triangle. Let's go to the second criteria, the second law. So the second criteria for a triangle to be congruent is when two angles and a corresponding side. This is two angles. Corresponding side means the side between the two angles. So this angle is equal to this angle is equal to this angle. As you can see, they indicated this is 1, this is 2 double stroke, and the corresponding sides Once you achieve that, the angle is what? Congruent. But there is a trick here. Is this a congruent triangle? Some will say no, because this side is not corresponding, it's not in between this angle, right? But there is a trick. The trick is that so long as this angle is equal to this, so long as this angle is equal to this angle and this angle is equal to this angle, since it's a triangle we are talking about, the total angle of a triangle is 180 degrees, total interior angle. So let's assume here now is 90. Let's assume here now is 90. I'm just giving an illustration. And here is 60. It means that I need, for this triangle, I need extra 30 to complete this internal angle to be 90, right? And let's assume here is 60 for there, because here and here is equal, and the same apply here. Here too is also be, I also need another extra 30 degrees. So once the two angles of a triangle are the same, it means that the third one will also be the same. So let me say here will now be like, I'll put like triple stroke. So for this second law, the side, once the two, you can just say that once two sides are equal, once the two angles are equal, I mean to say, and one side is equal, just know that it's congruent, because by default, once the two are equal, the third one definitely will also be equal to the third angle. So anywhere you have this line, you see that it's corresponding. In this case, it's no longer corresponding to the one we initially draw, but it's corresponding to another one. In this case, the same. If you draw it here, let's assume in the case of this first triangle, we have that this line is here. So I will say, oh, it's not congruent, it's still congruent, because this third angle will definitely be equal to this third angle. So this here will now be corresponding to these two angles here. If you draw it here, it's still the same, because this third angle will still be equal to this third angle, since the sum of a triangle is 180. So here will be corresponding to these two angles. So for this second law, just know that once you get the two angles equal and one other side is equal, it's congruent. So let's move to the next law. So the third criteria is when the three sides are equal. Let's say we draw a triangle and draw another triangle. Let me face this on this side. Let me call this R, S, T, and call this U, V, W. Now, if this side and this side is equal, this side and that side is equal, this side and this side is equal. See that example? See what I was telling in the previous place. See that here and here is equal, here and here is equal, but here and here is now equal. So we have to use double stroke. The third side, we have to use triple stroke. So once the three sides are equal, just know that is a what? Congruent triangle. Because once the three sides are equal, obviously, it might not be the same arrangement, but the one angle here will be equal to one angle here, one angle here, and so on. So this is not part of what I want to say. So once you have the three sides equal, this is a congruent triangle. So this one is very simple. Let's go to the next one. So the third criteria is right angle, hypotenuse, and one side equal. Mind you, these things are equal, they are not putting it. So it simply means, let's say we have a triangle like this, and we are doing with right angle triangle. So have another one, under right angle triangle. Let me call here E, F, and G, and call here K, L, and M. Here is right angle, here is right angle. So what they're trying to say is that when you have a right angle, the two hypotenuse must be equal. So here is equal to this. Then one of the sides must be equal to. Let me take this side for example. It means that this is a congruent triangle. Very simple. When you have a right angle triangle first, then the hypotenuse, what's the hypotenuse? Hypotenuse simply means the side that is facing the 90 degrees. So the hypotenuse must be equal, that's the second one. And then one of the side, it can be this side, it can be this side, but just know that one of the side must be what? Equal. So this is a congruent triangle. So let's test our knowledge on these congruent triangles. First law, let's recap. Congruent triangle simply means if a triangle have the same shape and size. It's like you have two these two triangles. We want to know if the both of them have the same shape and size. First is that the two sides and the included angle must be equal. The two sides and the included angle, the angle between the two sides. Second is that the two angles and the corresponding side, the side between the two angles. Third is that the three sides are all equal. While the fourth one is that we have a right angle triangle, hypotenuse must be equal and plus one extra side must be equal. So let's test our knowledge. So we are going to deal with a lot of examples to make sure that we understand this congruent triangle. So in this example, exercise 2b, we are given a lot of triangles and we are to ascertain if they are congruent or not. The first one, is this congruent? Yes. Because of what? It has two angles equal and the corresponding side, the side between the two angles are what? Equal. So A is congruent. I can say A is congruent. Plus. What about B? Is it congruent? Yes. The two sides are equal and the included angle 2 is in between the two sides. So it satisfies our law. B. Then for C, this C. Is C congruent? We have that the two sides are equal because this is equal to this and this is equal to that. But now this is the corresponding side. There is no way they confirm to us that the corresponding sides are equal, so we can't necessarily say that this is congruent. So this will take X. Then what about D? The two sides are equal. This is equal to this, that's equal to that, that's equal to that. So this is also congruent. Hope you are following up. I want to do the whole exercise so that we'll get used to this. What about E? We have two sides are equal, but the angle is not the included angle, because for us to be sure that this is congruent, this angle is supposed to be here. This angle that is equal is supposed to be between the two sides that are equal. So this is not congruent. What about F? For F, this is the right angle triangle rule, the fourth one we did. It has a 90 degree. First one satisfied. The two hypotenuse are equal. Second one satisfied. Then the one side also is equal. So this is also congruent. What about G? Abi, I mean, missing something. What about G? We have that this side is equal to this side is equal to this side, but the angle is not included. It's supposed to be between the two sides that are equal for us to be sure that it is congruent. So this is not. What about H? We have that this side is equal to this side and that side is equal to, but the angle is also not included. So we can't say this is congruent. I. This side is equal to this side, that side is equal to this side, and this angle is equal to this angle, and the angle is also included, the angle between the two sides that are equal. So this is congruent. So for J, we have two angles equal and one of the corresponding side. So here too is also what? Congruent. So when we go to number 2, we have been told to find the congruency and list out the criteria. In this case, I'll just do A and B so that, because these ones are more technical, so we don't waste so much time. When you come to the A, you notice that the right angle, both of them have right angle. First condition, that's R. Okay, look at what they told us to check out for. RHS mean right angle, hypotenuse, and one side. That's for the fourth law that we did. SSS meaning the three sides are equal. I think that's in the third one that we did. SAS meaning two sides and one included angle. That's for the first one that we did. ASA and AES meaning two angles and the corresponding side. So here we have AX, XYZ, and XZA. So both of them has right angle degree, right? And the two hypotenuse from the diagram, we have been told that two hypotenuse are what? Equal. So we just need the extra one side of this triangle to be equal to know it is congruent. Now look at the side both of them are sharing. So this side is equal, so this is congruent. Coming to the second one, we know that this side both of them are sharing is equal, so they don't need to give us line to us for us to know, because these two sides are the same for here and for here. We also know that look at another side now that is equal, which was indicated. Now look at the angle. This dot represents the angle. So this angle is included. Look at the angle is between the two sides that are equal for this side and also between the two sides that are equal for this side. So this is also congruent. So the criteria for this one is SAS, two sides and included, and while the criteria for this one is RHS. So let's go to number 3. That's number 3. Now we are being given a notation. So we have to reproduce the notation and check the congruence. I'll just pick out like 2 and solve. So this is number 3. In this case, we need to sketch. That's how I have to write it out. In each of the following, the statements refer to triangles ABC and PQR. So let's say, let me say this is A. For this first one, so we have two triangles A, B, C. Mind you, the order you use to write the alphabet for one is still the same order. I'm using A, B, C. And coming to the second one, I can't just come here and start writing P and then do P, Q, R. No, I'll use the same order I use it so that I'll make sure I'm not getting this messed up. So P, Q, R. This for the A. Let's go for the B. We have so many examples, but I just want to treat on A and B. You can solve the remaining ones by yourself. I have another A, B, C, and P, Q, R. So it's in each case, sketch the triangle. We've already sketched them, and mark in what is given. What is given is these are the things that are given. So we are going to mark them in, and then know if the triangles are congruent. So let's mark in for the first one. They say that AB is equal to PQ. So AB is equal to what? PQ. BC is equal to QR. BC is equal to QR. So in this case, I'll use double. So I don't know if this one's are equal. Then angle B is equal to angle Q. This angle B here is equal to angle Q. Can you see that if I did B now, I've used PQR, my angle Q will be this side, and in that case, like these two triangles are congruent, and we know that the condition for them to be congruent is SAS, two side and included angle. So imagine if I didn't follow that same pattern I used here, my Q will be here. So I will say they are not congruent because this angle will no longer be included if it's at this side of this triangle. So that's why it's very important. Any pattern you use, still use it for the second triangle. So these two triangles are congruent because we have two sides equal and the included angles are also equal. For the second one, AB is equal to RQ. AB is equal to RQ. AB, this is AB. This is RQ. So put it here. Angle B is equal to angle Q. This is angle B. And is equal to angle Q. Then angle C is equal to angle P. This angle C is equal to what? Angle C. So I've been asked if this is congruent. This is congruent because of what? Two sides of the two angles are equal. So once any of the other side is equal, it means that it's congruent. And the condition for this one is SSA. Abi, am I getting it? No, this is AAS, two angles and one side. So this is AAS, not SSA. So I think this summarizes our class on congruent triangle. I took our time and explained it very well. Anybody that followed this class, I don't think there's any other question in congruent triangle that the person cannot be able to answer. Thank you and see you in the next class.